Huntington's disease is a rare and progressive, genetically inherited autosomal dominant neurodegenerative disorder caused by an expanded CAG repeat in the Huntington gene and characterized by unwanted choretic movements and behavioral disturbances. Together, let's dissect this definition to look at the individual components comprising the disease. Let's start by looking at how the disease is passed down from generation to generation. Autosomal tells us that the affected gene is carried on the 22 pairs of chromosomes which are not sex chromosomes, and since the disease is dominant, if one affected allele is present, it will be enough to cause the disease. Using the example shown on the screen, if dad has the condition but mum does not, reinforced by the Punnett square diagram to the right, there will be a 50% chance of passing the disease onto the offspring. The disordered physiological processes associated with Huntington's disease arises from a CAG trinucleotide repeat expansion. All humans have the Huntington's gene, which codes for the Huntington protein, which is a large protein consisting of 3,144 amino acids found in highest concentrations in the brain and testes. At the N-terminus of the Huntington gene, located on the short arm of chromosome 4, there is a CAG trinucleotide repeat. CAG, which encodes for the amino acid glutamine, is repeated 9 to 35 times in healthy individuals, with an average median of 17 to 20 repeats. An allele containing a polyglutamine stretch exceeding 35 CAG repeats results in Huntington's disease.
This concept can simply be explained using Lego blocks. Imagine before us is a condensed version of the Huntington gene, and this blue block here represents the CAG codon encoding for the amino acid glutamine. In healthy individuals, CAG within the Huntington gene repeats from 9 to 35 times. However, in those with Huntington's disease, this CAG repeat will increase in length to repeat more than 35 times.
The age of onset of Huntington's disease is inversely proportional to the length of the CAG repeat. Those with 36 to 39 repeats have a lower phenotypic expression and later onset of the disease, while those with juvenile Huntington's who display symptoms before the age of 20 have more than 55 glutamine repeats. Furthermore, if the gene displays 28 or more repeats, although the individual will not develop the disease, gene instability will occur. 73% of gene instability leads to an increase in the size of the CAG repeat on replication. This helps us understand why the age of onset of Huntington's disease becomes earlier in successive generations and how new cases of Huntington's disease arise in individuals with a negative family history. But how does this polymorphic polyglutamate stretch lead to Huntington's disease? The role of the Huntington protein is yet to be fully understood. However, the protein is predicted to have vast functions in mediating normal physiological processes. Some of these functions include axonal trafficking and regulation of gene transcription. The most popular theory suggests that the mutant Huntington protein acquires a toxic gain of function which leads to neurodegeneration, causing the signs and symptoms associated with Huntington's disease. Huntington's disease causes selective neuronal death in the brain. It is characterized by intranuclear inclusion bodies, which are large aggregates of abnormal Huntington protein in neuronal nuclei. Particularly affected is the basal ganglia region of the brain. Within this region, Huntington disease targets neurons of the striatum, which play a critical role in voluntary movement and reward pathways. The main change is the loss of special inhibitory neurotransmitters called GABA. Up to 95% of GABAergic neurons located in the striatum are lost with the disease. In the normal brain, GABA is secreted to prevent movement. In Huntington's disease, however, there is degeneration of the neurons secreting GABA, resulting in uncontrolled movement known as chorea. Let's further explore signs and symptoms associated with Huntington's disease. Often the first symptoms present are behavioral symptoms. These include increased irritability, agitation, frustration, depression, apathy, hyper or hyposexuality, increased aggression, impulsivity, and an inability to recognize emotion. Cognitive decline is centered around the loss or impairment of executive functions. Patients lose mental flexibility, and learning and retrieval of new information additionally becomes impaired. Motor symptoms are heterogeneous. Several hyperkinesias, defined as abnormally increased muscular activity and including chorea and dystonia, can coexist with akinetic rigid symptoms. Akinesia is the difficulty in starting movement, while bradykinesia defines slow movement. Other motor symptoms include incoordination and difficulty in swallowing and speaking. Huntington's is a rare disease. Over 1,800 people in Australia have been diagnosed with Huntington's disease, and approximately 9,000 are at risk. Tasmania has the highest prevalence with 12.1 cases per 100,000 people due to past family lineage links.